Alright, let's look at this equation that has extraneous solutions, or that could have extraneous solutions. Whenever you have a variable on the denominator of a fraction, you have the chance of getting an extraneous solution. Why, you might ask? Because whenever you have a variable on the bottom, this denominator can never ever equal 0. So in this case, this very simple rational expression, we can see that x cannot equal 0. If it's a little more complicated, I mean, I don't think that's complicated, but it has that plus 2 on the bottom. X right here cannot equal negative 2, because if I plug negative 2 into this x, negative 2 plus 2 would be 0, and then you would have an extraneous solution if this was what you ended up getting. Not ending up with the extraneous solution, but ending up with an undefined number. You can never, ever, ever divide by 0. That is an undefined number. So let's go over here and start solving, and then we could talk more about extraneous solutions. Okay, there's multiple ways to do this. The way I'm going to show you, I think, is the most understandable way, but it's not my favorite way. I wouldn't do it this way. In fact, I'll go ahead and show you the other way I do it, that I would do it once I'm finished with this. So what most people might try to do here is to find common denominators for all the denominators. So I'm seeing this denominator right here, this denominator right here. They all look kind of similar. This one right here can be factored, and so you would be encouraged to factor this. Now that's a difference of squares. I know that because of the minus sign, that's a difference, and both of these are perfect squares. Oh, excuse me. And so we have x minus 2, and then we have x plus 2. All you have to do is have a minus and a plus. That's what a difference of squares will give you if you factor it. And then each of these numbers is the square root of this number and this number. Alright, so this is our new denominator for the 6x. Now you just have to look at the other denominators and see what they're missing. This one right here has an x plus 2, but it's missing an x minus 2. So you would want to multiply the top by x minus 2 and the bottom by x minus 2. Oh man, this is starting to look kind of sloppy. Let's rewrite this. We have 3 times x minus 2. On the bottom, we're multiplying it by x minus 2. And then we have 6x, our factored denominator, x minus 2, x plus 2. Alright, on the left side, we have 1 over x minus 2. So this side we're missing x plus 2. So I'm going to put an x plus 2 right here and an x plus 2 right here. Then you would simplify. So if I simplify the tops, the numerators, we would end up with x plus 2 on top of this one. I'm going to go ahead and make this back to x squared minus 4, left to right. And we have 3x minus 6. I get that by distributing this 3. On the bottom we have x squared minus 4. And then on the top here we have 6x, and then we have x squared minus 4. Okay, so now all the denominators are the same. So because all the denominators are the same, what we can do is we can multiply each side by x squared minus 4. And the beauty about this is that whenever you multiply each of these terms, since the numerator is the same as the denominator, they cancel each other out. And so then all these all get canceled out, and you're left with x plus 2 equals 3x minus 6, and then you have a minus 6x. Now let's pause here for a second. I want to go back to this guy right here. Alright, now the trick here is not to get stuck because of this minus. Now if I were to make this minus into a plus sign, I would just make that 6 into a negative. But if this 6x was like 6x plus 1, then you're going to have to distribute the negative to the 6 and the 1. That's an easy trap to get caught into. This problem doesn't have that trap, but I'm just showing it to you to make sure you don't get caught with that. Make sure you distribute your negatives whenever you're subtracting. Alright, so then we got some combinations to do here. We have a negative 6, so we have a negative 3x minus 6 equals x plus 2. I got to put the x's on the same side, so I'm going to add 3 x's to both sides. I get 4 x's right here, so I get 4x plus 2 on the left side. On this side, this adds to 0, so I don't have any more x's over there, but I have a negative 6. I'm going to minus this 2 to both sides, so I get 4x equals negative 8. My final answer is negative 2. Okay, so before we box this answer and call it a day and say that's our answer, what we have to do is check for extraneous solutions. So I'm going to go all the way back to the very beginning. Look at my denominators and say, alright, does the 2 work in all these? If I plug in negative 2 to this one right here, I get a negative 4 on the bottom. Okay, we're cool. So this one checks out. If I plug a negative 2 into this one, we have a problem. If I plug negative 2 into here, I get 0 on the denominator. So negative 2 is actually an extraneous solution. And since I did all this work to solve it and found that negative 2 is the only result I get, this has no solutions. Okay, so the answer is no solutions. Our extraneous solutions is negative 2, and actually we know that we can't equal positive 2, because if I plugged in positive to this one, then that one wouldn't work. So my extraneous solution is negative 2 because that's what I got, and it would make this denominator 0. Actually, I guess you would call this a restriction, not an extraneous solution. Only negative 2 is an extraneous solution, but these are the restrictions. You cannot have the denominators equaling, the x values equaling negative 2 or 2.